everyone, and welcome. Ever looked at a Formula One car and wondered how it can be so ridiculously light but also incredibly strong? Or how a massive jet can be efficient enough to fly across the globe? Well, today we're pulling back the curtain on the secret behind some of the most high-performance things in our world. We are talking about composite materials.
So, what is this big secret? What's the common thread that gives all these super things their amazing abilities? Let's put on our detective hats for a minute and uncover this mystery together. Okay, think about these three things for a second. A Formula One car, a huge modern airplane, and a professional tennis racket. I mean, on the surface, they seem completely different, right? But they all share one incredible secret that gives them their edge. Any guesses what that could be?
Well, the answer isn't a single material like steel or plastic. It's actually a team-up, a super powerful combination of materials, all working together. Think of it as a material power couple.
And that power couple has an official name, a composite material. The idea is actually pretty simple. You take two or more totally different materials, you combine them and you create a brand new one that is way better than the individual parts you started with.
To make this super clear, let's use an example I bet you've all seen. Reinforced concrete. Now, cement on its own is strong, but it's brittle. It can crack. Steel rods are also strong, but they're flexible. But when you put those steel rods inside the cement, boom, you get something way stronger than both. The cement acts as the base, the matrix, and the steel rods provide the reinforcement. And just like that, you've got a composite.
So every single one of these composite power couples has two key players. First, you have the matrix. This is the base material, kind of like the glue that holds the whole thing together. And then you have the reinforcement. This is the star player, the material you add to bring in the real strength and stiffness. It's a total team effort.
And this really gets to the heart of why we even make composites in the first place. The final material isn't just a simple mix. Its properties become fundamentally different, and pretty much always much better than the original ingredients. It's less like mixing two colors of paint together and more like creating a brand new color that never existed before.
So now we get what a composite is. But, just like in cooking, you don't use the same recipe for every single dish. So let's take a look at a few different types, each one engineered for a very specific job. We usually classify composites by their matrix. So for something that needs to be light and strong, like a pro bicycle, you'd use a polymer matrix, like carbon fiber. For something that needs to handle really high temperatures, like engine parts, a metal matrix is what you need. And for something truly extreme, like the heat shield on a spacecraft, you need a ceramic matrix. Different needs, different recipes.
So where do you actually find these incredible materials in the real world? The answer is pretty much everywhere. Let's take a quick tour.
I mean, seriously, from the aerospace industry making planes more fuel efficient to the medical field creating stronger artificial bones, composites are all over the place. They give us an edge in sports, they make our bridges stronger, and they even help us explore the deep sea in submarines. They really are the invisible, high-performance backbone of our modern world.
But, like any superhero, composites have their kryptonite. They are amazing, don't get me wrong, but they're not perfect. So let's get into the pros and cons.
And it really all comes down to a trade-off. The biggest win is that incredible strength-to-weight ratio. They're stiff, they don't rust, and you can shape them however you want. The downside? Well, they're expensive to make, they can be really complex to manufacture, and if they break, they're a pain to repair. And recycling them? That's a massive challenge right now.
Here's a perfect example of one of those merits in action. A carbon fiber bike is just an engineering marvel. It's unbelievably strong and rigid, which means you get maximum power when you pedal, but it's so light you can literally lift it with one hand. That's the strength-to-weight ratio working its magic in the real world.
And here's the flip side. If a carbon fiber part on a high-end car gets a crack, you can't just patch it up like you would a metal panel. The entire complex part often has to be replaced completely, which is both super expensive and pretty wasteful. This really shows you that difficult-to-repair problem.
So after weighing the good and the bad, what does the future really hold for composites? Are they truly the super material that will build our future?
So let's do a super quick recap. A composite is a team-up of a matrix and reinforcement. You can find them everywhere, from airplanes to tennis rackets. The huge advantage? They're incredibly strong, but also very light. The major drawbacks? They're costly and a real challenge to repair or recycle.
So, this leaves us with a final and pretty crucial question. These super materials are absolutely changing our world, making everything faster, stronger, and more efficient. But
Are we going to be able to solve their biggest problems? Can we figure out how to make them cheaper, easier to repair, and truly sustainable? The future of these materials really depends on finding that answer. Thanks for joining me for